Welcome to Versatile Test Tree Studio Embedded System Test Automation webinar. In this presentation, we are going to walk you through the main features and capabilities of this cloud-based network edition and show you how you can facilitate the testing of your embedded systems. Before we start with the demo, it is important to take a look at the main functions of this tool. This platform is designed with 4 main engines with different functionalities. Test Tree Manager. This engine is used for product and process flow management. Product managers and project supervisors are the main users of this engine. Test Tree Creator. This engine is the test automation creator and editor. Test engineers and technicians are the main user of this tool. Test Tree Runner. This part of the tool is to execute the test cases and is mostly used by the operators. And finally, Test Tree Presenter is the real-time reporter which shows the test results in form of statistical analysis and graphics. This engine is mostly used by product managers and test engineers. Versatile Test Corporation has developed a unique and revolutionary approach and execute of test cases in the electronic industries. This tool will allow the electronic manufacturing service to reduce the time to implement test procedures for their electronic devices by empowering test engineers and by reducing their needs to code software or to engage additional development efforts. The key innovation of this platform is as follows: virtual connectivity across all levels of NPI partners, standardized test engineering process with codeless test make automation, a complete end-to-end solution in one software package which allows to simplify and accelerate test development, to make it easy to maintain test process and database, and reduce cost and increase productivity. And finally, to automate test tool for hardware test engineers and product management. The following pictures will show how simple it is to create a test case using Test Tree Studio modules based on ATE versus the traditional methods with extensive and complex script and programming. This cloud-based platform could be used from different locations based on the secure network connectivity. As you can see in this slide, the architecture of this tool is designed in such a way that the test engineers working from Canada and US could create a test automation case for a specific design and store it in a SQL secure server. Other staff located in China and Mexico are in charge of test maintenance and manufacturing would be able to access the test cases to modify and run the test sequence and store the final results into the database. In this picture, you can see the I2C embedded system test setup based on the National Instrument Bridge interface to communicate to the UUT PCB. This example will be shown in more details once we show the Test Tree Studio test case creation. The following shows the codeless test automation modules and how I2C will help you to create your test cases much easier and more efficient. Test Tree Studio is combined of 3 main sections which includes different modules. These modules are as follows: standard modules, advanced modules, and embedded modules. Embedded testing, codeless test automation. The following steps are going to be presented. Step 1. Design and build test using Test Tree Creator. In this step, we'll show you I2C register read, I2C register write, module initialization of I2C, register read and write validation, CANBus module initialization, and CANBus register read and write validation. Step 2, we're going to be launching the test case using test tree runner. And finally, in step 3, we'll find the test result using test tree presenter. I2C read register. Select the USB port. In this case, it's going to be USB 0. Select the address. Read. And in the communication window, we're going to be seeing the read, the size, and the data. Let's change the data size to 255. Read. As you can see, in the same address, we have a size of 255 and the actual data contains 255 bytes of information. I2C write register. Let's select the address, in this case 50, and the data that we want to write into this address. We send the data, and in the communication window, we can see the data that we sent to this address. Let's change the data to FF00FF00 and resend it to the same address. As you can see, it's showing the actual data that we just sent to the same address, FF00FF00. We can also change the data size and read it back. The data received is what we had initially in there, plus the remaining data. I2C module use case. In this part, we're going to be creating a test sequence using I2C. Let's select the embedded module section. You can drag and drop the I2C module into your test sequence. This allows you to create your test case. Let's give a module name. In this case, it's going to be I2C demo, and a spec ID, which is I2C register validation. Now we are going to import the device ID. The next step is to scan the USB port and import the configuration from the device. I2C module test specifications. On the test module properties, we can select the result submenu and edit a spec to provide the design requirements. A window will pop out which allows the user to create its own design requirements. Scan. Two addresses, 38 and 50, has been scanned from the design. Let's select these two addresses. Select Import, which brings these two addresses into the window. From the Edit Spec window, click and specify the type of value you want to test. In this case, it's going to be a bytes and hexadecimals. In the spec key ID, provide a name and a minimum and a maximum value for this address. For the address 50, we will do the same thing, a hexadecimal with two different IDs. A minimum FF a maximum FF. We select. We do the same thing with the different address 04 and the value 04 for the minimum and 04 for the maximum, and we select. OK the results. And click the button Run. As you can see, the selected spec and the selected IDs are exactly the same as what we have specified in your test requirements. These results status are shown here, and you can also monitor them in the communication windows. The next step would be to apply and exit this window. This brings us to our main tool, where you can apply the complete test results to be run. By clicking the Try It button, this will go and test what you have specified in your requirement. And as you can see, the result is positive with no error. CANBus module use case. In the same way that we did for I2C, we can select from the embedded module section the CANBus, send and read, and drag and drop it into our test case. Let's provide a module ID and a spec ID to this module. From the test option, let's select the read first value to validate this spec that we have just defined. In this scenario, it's going to be read first value to validate, and we can give the test time to be 5000 milliseconds. Let's click the Results submenu and provide the edit spec to this design. In this case, we have a channel 1 and a channel 2 to be virtual CANBus. Let's select the channel 1 and import this channel into our window. Let's edit the spec. A window will pop out the same way as I2C. We can provide the scan data from this part, and all the data has been scanned and finished. CANBus test specifications. By scanning the data, the tool will grab all the information and provide it in terms of key ID, the data, the channel, and the size. As you can see, we scan the CANBus data within 5000 milliseconds. Let's select these data and import them into our property windows. By selecting the spec, we can identify what type of information we are going to compare. In this scenario, we are going to have a byte, and the value types are going to be hexadecimal. Let's provide the spec key ID each of these data. In this case, we're going to just select a couple of them. Register 1 with the spec minimum of 02 and a spec maximum of 02, and select this register. OK. Let's run this test. As you can see, all the information have been compared, and the result for all of them has been passed. Let's apply and exit this window and apply it to our main tool and save the test case definition. Try it, and the test result is positive with no error. We can do the same thing to validate with a different condition of the test case. Select the setting. In the setting area, you can see the test options: read first value to validate, read last value to validate, and wait for a target value. In this case, we are going to select read last value to validate and apply. On the results submenu, you can edit the spec. As mentioned, the test time is 5000 milliseconds and you can apply run to run the test. During this test stage, CANBus module will wait till 5 seconds to grab the test data. All the results have been passed. Test tree runner deployment. At this stage, we are going to be running all the test cases which we have created previously. By scanning the unit barcode, a window will be popping out with the serial number, product ID, and release number. Once the information is identified, you can OK this window and go to the next step. All the test cases are shown on the right side of Test Tree Runner. The next step is to run these test cases. As you can see, a series of information will be asked to the operator to validate certain criteria. All the tests are sequentially processing and the result are shown in the status window, whether it is processing, passing, or failing. A remaining time for each test is also shown in another window. The current process has been tested successfully. That means all the tests have been processed with the positive result and no errors. By clicking yes, all the results are stored into the database. The last step of this presentation is going to be the test tree presenter. Once all the test cases have been completed, the test tree presenter will communicate with the SQL server to grab all the information and show the final results in form of statistical analysis and graphics. As you can see, the total number of the product along with the test results are shown in this window. We can also go into more detailed results by selecting the product serial number, and by doing that, this result will help the upper management to better understand the production activities and the production results. In this specific example, the I2C test results are extracted from the database and are shown in this window. The status of all test cases are shown as passed. In this window, the presenter will allow the user to see the spec ID, spec value, and the status of the test. In this case, all tests have been passed. On behalf of Versatile team, we would like to thank you for attending this webinar, and we hope to see you for the other webinars coming in next month. Thank you.